schools of thought on how to solve these. I'm going to try and just tell you the easiest possible way. Okay, now, don't have any variables in the denominator in this first question, right? No variables in the denominator. Okay. Okay. If you don't have any variables in the denominator, which I don't in this very first question, I have x over 3 plus x over 11 equals 42. The easiest thing I could tell you to do is we're going to dispose of the fractions by trying to think of a number that both of these denominators would go into. Can you think of a number that 3 and 11 would both go into? 33. Okay, so basically if you can think of like the lowest common denominator between those fractions, here's what I'm going to do. I'm going to multiply everybody on both sides. Think about that as like 33 over 1. So if you want to skip this step, if it makes sense to you, that's completely fine. But this first problem, or first little term here, would become 33x over 3. Then it would be 33x over 11. And then I'm going to grab my calculator and figure out what 42 times 33 is. This would be 1386. Now, if we picked a number that both of those denominators would go to, that should just cancel those fractions out. So like 33 divided by 3, this is really 11x. 33 divided by 11, this is really 3x. And then this is this equation we're going to solve here. Just combine like terms there, 11x and 3x would be 14x. And I don't know if that divides evenly into 1386, but we're going to find out. And it does, bless. All right, I'm dividing both sides by 14. X is going to be 99. And I never have a variable in the denominator in that question, so there's no potential for me to have, there's no potential for an extraneous solution because there's no variable in the denominator, so I couldn't necessarily divide by 0. Okay, what in the next question I might recommend is to create a common denominator, okay, because I do have variables in the denominator. If you look at all three of those lovely fractions, what would be a common denominator between a, 9, and 9a? Be a common denominator. It's okay to have a variable in it. 9a. Okay, so we're going to put in what we need. Remember, you can't add. It has to be multiplication by 1. So this first fraction would need a 9, top and bottom, to make that denominator. The second fraction would need an a, top and bottom, to make that match. Okay, now I'm just going to do this for this question. So on the first fraction, 9 times 6, you'd have 54 over 9a. On the second fraction, you would have 4a over 9a. And the third fraction, I didn't have to change that because that already had that denominator as 9a. Now here's the deal. I didn't do this on the last question because I didn't have a variable in the denominator. I did have a variable in the denominator here, so what I did was create a common denominator with you guys between all the fractions. Here's what you can do. If you make all the denominators match, you can literally just cross this out, because if those are all equal, that would stay the same, and it forces just the top of that to be your equation. So the equation you'd solve, you would do 54 plus 4a equals 2. So if you can make all the denominators match, you can just cross them right out and just solve the top of the fraction, because the denominators would be the same if you added them together on that left side, and it would match up with the right. So you just work on the top. So I'm just going to subtract 54 here real quick. And I would get 4a equals, what, negative 52, and I'm pretty sure that's a nice number. Yes. So a is negative 13 there to make that true. And on this one, I would tell you, a could not be 0. If I had gotten 0 as my answer, that wouldn't have worked, but we got negative 13, so we're good to go. That should be your answer. So I just made all the denominators match. Okay. What would be a common denominator, because I do have a variable in the denominator, between 3, 5, and y? 15y. Okay, so to get that to happen here, I need 5y, top and bottom of the first fraction. The second fraction, I would need a 3y, top and bottom. And the third fraction, I would need a 15. So then they'd all have 15y in the denominator. So if you want to skip this step and just look at the numerator, you can. This would be 5y over 15y for the first fraction. This would be 9y. I'm just doing 3 times 3y. You can always multiply 15y. And then, oh my gosh, my brain stopped functioning. What is that? 90 over 15y. If you can make all those denominators match, if I actually subtracted that, the denominator would be the same. So you could literally just cross it out and just focus on the numerator to solve that problem. So you would have 5y minus 9y equals 90. So it would be negative 4y equal to 90, and you're just going to divide by negative 4. And I don't think that's a nice number. It's not, but that's okay. I got negative 22.5. Or if you want to do a fraction, this is negative 45 over 2. Either way, whatever's easier for you. Is anybody having a question? It's not terrible. That's a little bit, if you look at a textbook or something, it would show you a different way to do that with proportions, and it ends up being quadratic and all this other stuff. If you can just make all the denominators the same, that makes these problems so much easier to solve. Okay, so kind of the same thing. If you don't have a fraction, which I don't have in 2 of the terms in this next example, I'm just going to turn it into a fraction. Even if it's a variable, you can turn it into a fraction just by writing it over 1. And I promise you that, I don't know why, oh, sail at life. Okay, that should be over 1. I promise you this is the easiest way to do this. What would a common denominator between all 3 of those fractions be? C. Okay, so here's what I need. I need a C, top and bottom here. I don't need anything in the middle. I need a C, top and bottom here. So that would create, we'd have C times C would make it C squared. And then the one in the middle, I don't have to change that. And this one, I'd have negative 5C over C. This is a little harder, but this is the easiest way I could get you there. So all the denominators are C. So that forces just the numerators to be equal. So we can just work with the top. Now this guy's going to end up being a quadratic. So I have C squared plus 4 equals negative 5C. And I promise if you get a quadratic, I will make it factorable. So what I would tell you here, let's set this equal to 0. So you got C squared plus 5C. I'm just going to put that in between those 2 terms. Equals 0 here. And then no number in front of the C squared. Awesome. So my factors are just going to both start with a C. And can you guys think of 2 numbers if you multiplied them, it'd give you 4, add, you get 5? 4 and 1. So just one of them's a plus 4, one of them's a plus 1. Now, what are the actual answers to that? Because that's 2 factors set equal to 0. Negative 4, negative 1. The only number that would cause me a problem in the original problem would be if C was 0, but we didn't get that, so both of those answers will work for that question. Does anybody have a question? Okay. Now, let me look at this next one. I would tell you for this one, this is more similar to that very first question we did. I don't have any variables in a denominator here. If you don't have any variables in a denominator in the bottom of the fraction, I would just try and find a number that both 2 and 3 would go into. Can you guys think of a number that 2 and 3 would both go into? 6. Okay, so here's what I'm going to do. I'm going to multiply everybody by 6. This is a little different than that first question because I've got 2 terms on the top. So here's how I'm going to write this. So for that first one, I'm going to write 6 times x plus 3. That would be over 2. We got subtraction here in the middle. Then I'm going to have 6 times x minus 20. You got to make sure to put that in parentheses because you'd have to multiply 6 by both of those. But I'm going to hold off on that for a second. Over 3. And then on the other side, 3 times 6 would just be 18. Now, if you picked a number both of those denominators would go into, we should be able to get rid of both of these fractions. So this fraction, you got a product on the top. 6 divided by 2, totally allowed to do that. This would be 3. We'd still have to do a little distributive property, but I'm just trying to save you a little time. The next term, 6 divided by 3, out in front we'd keep a 2. You'd still have the x minus 20. And then you'd have the 18 on the other side. So this is a little more complicated than a couple of the other problems, but we're just going to do a little distributive property here, and then we'll combine some like terms. So you got, what, 3x plus 9. Now, if you're subtracting these two fractions in the original problem, I would just distribute that like a -2. So -2 times x would be -2x. -2 times -20 ends up being +40. And when you distribute it that way, you're distributing that subtraction sign as you do that. So then you just combine like terms. So we got 3x minus 2x, so that's just 1x. 9 and 40 would be 49. And all I got to do is actually just one step. I got to get x alone. So I'm going to subtract 49 from both sides. So I have 18 minus 49, which is -31. And I never had a variable in the denominator in any of those fractions in the original problem, so you don't have to worry about an extra solution. Is anybody having a question? Okay, so my recommendation to you, if you don't have a variable in the denominator, just multiply everything by something that would go into both number denominators. If you do have a variable in the denominator, try and create yourself a common denominator. So these are going to be a little trickier on the back. Okay, now, a couple ways you can do this. So obviously these denominators don't match. I could create a common denominator between these two fractions, which would be exactly the same as just solving this like a normal proportion. So it's totally up to you. If I created a common denominator, I would multiply top and bottom of this first fraction by x minus 2. I'd multiply top and bottom of that second fraction by y plus 1, but it would be the same action as just doing a cross multiplication. So if I have that, I might just go ahead and do just normal proportion, like from Algebra 1. So this would just be careful with this. If you got two terms, you have to use parentheses and distribute. So I'd have 6, the cross product would be that y minus 2, and then we'd have 5 times the y plus 1. And if you want to skip that step and go ahead and just multiply, that's what I usually do, but it's up to you. So this would be 6y minus 12, and then 5y plus 5. Now, if I'm solving this, totally up to you. I like to try to keep my variable positive if I can, so I'm just going to do 2 steps in one. I'm going to subtract 5y, that'll get all my variables on the left. And I'm actually, let me just add the 12 in the same step, because I didn't leave a lot of space here. So we'd end up with just 1y and then equals 17. And I don't have to do anything else. In this situation, though, make sure you check. In the original problem, if I'd gotten -1 or if I'd gotten 2 as an answer, that would cause the denominator in one or both of those to be, or one or the other of those to be 0. And so if that happens, then you might have an extra answer. So just nothing in your answer could make a denominator 0. Just keep that in mind. Okay, now on this one, would you cross multiply? What would you do? Yeah, the denominator matches, right? The denominator is the same, so that forces the numerators to be equal on either side. So literally all I would do here is just y minus 2 equals 4. You already have, you could cross multiply. If you cross multiply there, you're going to get a quadratic, and it's going to take you a lot longer to solve it. If you notice that, hey, those denominators are the same, just cross them right out, then you could just solve this little equation, and I get y equals 6. Does that being my answer cause a problem? Yes. Okay, if you guys look at this, if we'd plug in 6, that makes that denominator equal to 0. This is not good because that makes our denominator equal to 0. So actually this question would have no solution to it. 6 is the only number I could not get as my answer, and that is exactly what I got as my answer, so that equation is just not going to have a solution. So that can happen. Okay, now this one is going to be tricky. So do you guys see how there's like a little negative out in front? Okay, now this is completely your choice, but what I would recommend here is to attach that to either the top or the bottom. I would personally attach that negative to the top of the fraction because it just has one term. Because if you put that negative on both parts of the fraction, it would actually cancel, like a negative over negative would actually cancel out and make that positive. Now, this one is similar to the question right above it, where it's going to be just as much work to do a common denominator between both sides as it would be to just go ahead, let's just cross multiply here. I would just cross multiply on that. You can't reduce anything on either of the fractions, so the easiest way to do this one is probably just like a normal proportion. Now, I have one of the cross products would be negative 3a times a minus 9. The other cross product would be 3 times a plus 15. So I'm going to have to do a little distributive property. All right, and I'm not going to lie to you, we're going to have a quadratic on this question. Now, negative 3a times a is negative 3a, but then it would be squared. Negative 3 times negative 9 is going to make this plus 27a. And then on the other side, I've got 3a, and 3 times 15, I don't know why I wrote such a big number there, is 45. Okay, now, if it's me, set this equal to 0 because you're going to have quadratic, but what I would recommend here, I'm going to want my squared term to be positive, so I'm going to actually add that 3a squared to the other side, and then that's going to cause me to subtract the 27a, just to do it in one step. So these guys will be gone. There's nothing to combine the 3a squared with, but when I add it to the other side, makes it positive, make it easier to work with. For the a's, you got 3 minus 27, so it'd be negative 24. And then just the 45, there's nothing to combine that with. All right, what do you all notice about all numbers in that quadratic? They have anything in common? 3, 24, and 45. 3. Okay, so get rid of that. Don't try to factor this. Get rid of that. If you do that first, you can always divide 0 by number, completely legal. This becomes a squared minus 8a, and then plus 15. Okay, I promise if you get a quadratic, it will be factorable, and this is nice because I do not have a number in front of the a. So on this guy, we got to have two numbers. When we multiply them, we get positive 15. Same two numbers when I add them, I get negative 8. Can we think of two numbers that would work for that? Yeah. Perfect. Negative 3 times negative 5 is going to give you positive 15, and then added together, that's going to give you negative 8. Now, what are my actual answers, though? 3 and 5. And then just before you write that, just do a little quick check. Make sure two problem numbers here would have been negative 15 and positive 9. So I didn't get that for either one. So then both of these will be answers for that equation. Okay, now I'm going to do one more. Is anybody having a question so far? Okay. Now, there's kind of, I would tell you if you get something like this, where something in the denominator looks like maybe it could be factored, let's do that. So for what I mean by that, that first fraction on the bottom, do 2 and 8 have anything in common? Like on the denominator there, 2y minus 8. Could I factor that a little bit? 2. Okay, what would be left? Perfect, y minus 4. Okay, now, leave it. I'm just leaving the top of this next one alone. Can you guys factor, that one's a difference of squares, y squared minus 16. So multiply to get negative 16, but add it to 0. Yes, ma'am. Okay, so one's a y plus 4, one's a y minus 4. Okay, now the other side actually had the same denominator as the very first question, or first term, sorry. So I'm just going to pull a 2 out. And in this particular problem, we've got variables in the denominator. So what I want to put into this is to create a common denominator between all three of them, and that's probably the easiest way for me to tell you to solve this. Okay, now, this guy is missing. What's the first term missing if I want to try to create a common denominator? Y plus 4, right? All right, sorry, I should have left some more space. What is the second term missing? 2, just the number 2. Okay, now, when you do this to the top, you're going to have to do a little distributive property with the 2. All right, and then this third fraction is missing the y plus 4. All right, now, by doing that, we made all the denominators match. And if you didn't do this, you'd have a quadratic. But if you do match all these guys up, you won't have a quadratic. Okay, so the top of that first fraction you've got 10 times y plus 4. So we got to do a little distributive property, no big deal. The second fraction, I have to multiply that by 2. I'm subtracting that. Let me just write the 2 in front of the parentheses. That's the same thing. And then the other side, we have negative 8 times y plus 4. I mean, it's a little complicated, but there's nothing quadratic there. There's nothing squared. We're just going to do a little distributive property on both sides. All right, so I'm going to get 10y plus 40. Now, I'm going to distribute that subtraction, so just distribute that as a negative 2, and that'll take care of the subtraction. So minus 14y minus 16. The other side would be negative 8y minus 32. If it's me, I just want to combine like terms on that left side real quick. So 10 minus 14, you got negative 4. And 40 minus 16 is 24. And then it is totally up to you. If it's me, I try to make it so my variable will be positive. So if I was doing this, I would add the 8y to the other side. And I'm just going to do this in the same step. I'm going to subtract 24. Now, negative 4y, if you add 8y to that, that's going to give you 4y. And negative 32 minus 24, we're getting more negative. So this would be negative 56. And then I'm just going to divide by 4 real quick. And as long as my answer is not 4 or negative 4, we should be good to go. So negative 56 divided by 4, I got negative 14. That's not going to cause me a problem in any of the denominators. Once you get a common denominator, if you get something like this, it's really not bad to solve it. It's just, it might be a couple steps with the distributive property.